Hello, welcome to class. Today we have an interesting problem taken from London University Schools Examination Board. It has to do with the exchange of heat. We are told that the hot water tap of a bath delivers water at 80 degrees Celsius at the rate of 10 kilograms per minute. That means every 1 minute, 10 kilograms of hot water flows into that bath. The cold water tap of the same bath delivers water at the rate of 20 kilograms per minute, and the cold water is at 20 degrees Celsius. We are asked here, assuming both taps are left on for 3 minutes, calculate the final temperature of the bath water, ignoring heat losses. When you are told to ignore heat losses, the assumption is that there is no exchange of heat between the system and the surroundings. So all that happens would be within the system itself. Okay, so since we are told that the two taps run for 3 minutes, we need to obtain what's the masses of hot water and cold water that will run into the system in 3 minutes. That's what we are going to obtain for. So let's do it together. So for the hot water, so we begin with hot water. Okay, so let the mass of hot water be M1. And what would that mass be? If the rate of flow of hot water is 10 kilograms per minute and the tap runs for 3 minutes, so the mass will be 10 kilograms per minute multiplied by the duration, which is 3 minutes. So we shall have 10 kilograms per minute and then multiply by the duration, which is 3 minutes. Okay, so the minute will do away. 10 times 3, that will give us 30. So that means the mass of hot water that flows for 3 minutes is 30 kilograms. So for cold water, let the mass of cold water be M2, and the rate of flow of cold water is 20 kilograms per minute. And if it flows for 3 minutes, what's the mass that actually goes in? That's going to be 20 kilograms per minute multiplied by 3 minutes. Okay, so the minutes will cancel. 20 times 3, that will give us 60. So that means 60 grams of cold water flows into the bath in 3 minutes. Remember also, quantity of heat at any point in time equals to mc theta. M is the mass, C is the specific heat capacity of the substance, and theta is the change in temperature. In this case, hot water is losing heat to cold water. Heat loss is going to be heat gain. So for the hot water, M1 C theta, as heat loss by hot water, will be M2 C theta. Heat gain by the cold water. Since the substance is the same, the specific heat capacity stays the same, so we can simply cross them off. So we have that M1 here, the mass of hot water is what, 30? Theta is the temperature change. Remember, the hot water was initially at 80 degrees Celsius. So when it mixes with the cold water, the temperature will drop. So let's assume X is going to be the final temperature of the mixture. So the theta, or change in temperature, will be 80 minus X for the hot water. For cold water, the mass we know is 60. And definitely the final temperature will be higher than the initial temperature of the cold water here. So the change will be X minus 20, where X is the final temperature of the mixture. We expand this, we will have 2400 minus 30x, okay, equals to 60x minus 1200. The next thing we do is to rearrange correct like terms. So when we do so, we'll have 2400 plus 1200 equals to 30x will go over. We have 60x plus 30x. So on the left hand side here, this will give us 3600. The summation of 2400 and 1002. While here will be what? 90x. The coefficient of x on the right hand side is 90. So we divide both sides by that 90. When we do so, we'll have that 3600 divided by 90 equals to x. 90 is a factor of 3900. So 90 would divide itself, it goes here 40. Okay, so what that means is that x equals to what? 40 degrees Celsius. That's the final temperature of the mixture. Do well to like, follow, share our pages on all platforms, on Facebook, on Instagram, and also on YouTube. Thank you.